Okay, class, I told you I would go back and take a look at our first problem and take a look at the units that they were using and why they ended up with these numbers. If you could take a look at page 255 or 225 rather, the plane took 4 minutes and 20 seconds in one direction, and then it took 3 minutes in the next. So let's turn over to 226, and we're going to see what they did with that. And it's at the very top of the page. They had to convert. It says its time flying against the wind was 4 minutes and 20 seconds, which is equivalent to 260 seconds. Well, how do they get that? Well, let's go over here and say we have 4 minutes. Okay, and if we multiply that by 60, right, 60 seconds per minute, we would end up with 240 seconds, and then we would add 20 seconds to that, and that gives us 260 seconds. So they had to convert this all the way down to seconds. Now, because it was being measured, or the wind speed against it was being measured in hours, they had to convert this into its or the fraction of the hour. Okay, and for us to determine that, we have to realize that there's 60 seconds in every minute, and there's 60 minutes in every hour. So we have to now divide this by that factor. Okay, so and again, I could just show you. Let's see, 60 to 60. If we were to divide this, we'd have to say, well, there's 60 seconds in a minute, and if we were to divide this, it would be actually somewhere close to what? It would be 4.3, I think the answer would be, simply because we have 4 minutes. So this would be in minutes, right? But if we were to do it in hours, how many hours? That would be 260 seconds divided by 60 minutes. And then you have to divide that by 60 minutes as well. Or just multiply in the denominator here by 60, and that would give us the hours. Okay, and if you did the math according to them, that would be 260 seconds over 3600. Oop, that's 200. Looks like a 266. My pen just flew off there. 260 divided by 3600, which is basically just 60 times 60. And this would be the hours, so the measurement in hours. Now, why are we doing this and what makes sense about it? Well, if I told you that something was 6 inches tall, okay, and you'd say, okay, it's 6 inches tall, okay, it's like a little vase, all right, and now I tell you, well, how tall is that in feet? Well, you would say, well, it's 6 inches divided by, there's 12 feet, right? 12 inches in a foot. So you divide that by 12, and you say, oh, it's a half a foot, 0.5, right? 0.5 feet, right? So you of the measurement in feet, it's half. Notice how it got much smaller than the 6 inches, because the 6 inches is a smaller measurement of distance. And now if I told you and I asked you, well, how tall is that in miles? And you might say, whoa, I don't know. Miles is a very long distance. Well, I can tell you right now there's 5,280 feet in 1 mile, which means we would have to take this 0.5 and divide that by 5,280 feet. And this would tell me how many miles. Okay, so this would be the measurement in miles, and obviously that's just going to be a wonderful number. In fact, I can tell you right now that that number would be 10,560th. Okay, so it will be 1/10,560th of a mile. Which is a fairly small number. If you were to convert that into the into a decimal, the number would be quite small, wouldn't it? You have a lot of zeros after that point, 0.000. And here's what I'm going to just suggest to you is that when you're looking at distances that have, or excuse me, other measurements that have varying measurements, you need to understand first what are you measuring so that you can always convert to that measurement. You never want to use the measurements in a disproportional form. And what I mean by that is that if we would have taken 4 minutes and 20 seconds and simply say that's 260 seconds and use that when we're talking about a distance that is, or a time that's measured in hours. Remember, we're told that the resistance was 2 miles per hour. It would have really thrown our equation off completely. And in particular, it would have thrown it off because we're measuring we're using miles, we're using hours, and we're using seconds. So everything has to be in the same type of time measurement, the same type of rate measurement, whether it's miles per hour, meters per second, meters per hour, I mean, whatever it is. Distance, if it's in miles, is it in meters, is it in inches? And as math gets a little more complicated, particularly the science side, where you're applying it, you're going to need to understand these conversions, okay? And you can always take time to practice that and understand what your conversions are, but it should make sense. And if we go back and we take a look at 6 inches, 6 inches is a whole 6 inches, but it's only a half a foot. Okay, so the number is getting smaller. And it's 1/10,560th of a mile. Okay, so we can see that it's fractionally so much smaller when we're talking in terms of the unit of measurement. So you should always pause. Had I told you 6 inches is the same as half a mile, you'd have to stop and say, no, it isn't. It's not even close. It's a half a foot, yeah. So you have to pause, think logically. And when you're doing conversions, there's more to conversions as well, how you handle the units. We'll cover that throughout the course of time, but something that you should have already learned as well. So this is, and the reason I removed this from our original problem, and if we look, there was also 180 seconds. We knew it was 3 minutes. If we're looking at page 226, there's 3 minutes, so it's 180 seconds. So what did we do is we plugged that in as the time. And it was if you look at the illustration right in the middle, 260 over 3600 and 180 over 3600. It really complicates our equation here, and I think it takes the focus off of what we were trying to do. And it was trying to we were trying to look at the relationship between the two pieces of information and how we can create an equation. So that's really the reason why I did that. I feel that anyone can do these types of problems that has already learned how the mathematical laws are applied, but at the same time, you're going to lose focus on what you really should be learning. And what you should be learning here is how to create an equation based off of all this wonderful wording that they've given us. So, and if you look as you read down, you could see how they applied these two expressions over the same distance, and you ended up with x minus 2 in parentheses times 260 over 3600, and that's equal to x plus 2 in parentheses times 180 over 3600. And again, that time is just represented. I made it simple with a 4 and a 3. But in this case, they had to convert. They had to do a lot of conversion. And to me, it was probably a lot more than what you needed to see. And so we won't fault the author for that. He's just trying to make you learn more things at the same time, or at least apply certain things. But I want to make sure that your focus was completely on creating the equation. Okay? So you can see how they did these conversions. Now we'll move on to our exercise problems.